Hello, welcome to another episode of Let's Make It. Last week we talked about LCD displays, and I'll tell you what, I'm going to extend that a little bit into this week for a couple of reasons. We had a couple people ask questions about the serial, which I said I was having interface problems with last week. I have since figured that out, and I actually had a friend of mine even say that he was using one of these. I don't know if he was actually having problems with it or whatever, but he suggested it be another episode. And it just kind of makes sense that while we're talking about LCDs, we get to talk about this now. So going forward, if you do have one of these serial interface LCDs, you'll understand it a little bit better. And I will say it was difficult. I actually purchased a sainsmart LCD that was a serial I2C LCD. And we're going to talk about that today and some of the problems I ran into. And I actually have a library you can download off the website when this gets put up there in the show notes. So if you're having the similar problem, because the code that comes with it off the web does not work. And I have rewritten the library so that it does work now, and it works pretty easily as well. So that'll all be online with sample source code and all that on the website. But I wanted to talk about it a little bit because one of the reasons you go to serial interface LCDs is to save pins, and I want to demonstrate or show you what the difference is in the number of pins that actually get used, and I can show you the display. And I also have the other display, the graphic display, starting to work. I'm just experimenting with it at this point. I'm not going to go into great detail with it today because I'm actually going to write a library for it. And I'll talk about some of the drawbacks of the native display by itself versus what I'm going to do with it in the future. And that won't be next week. It's going to take me a lot longer than next week to write that library. So what I first want to do is hop over to the computer, and I'm going to talk about how we did it last week, and then how a serial LCD works and the benefits to it, and then the protocol, the I2C protocol a little bit. And then we'll go over and hop a look at some code, and I'll show you the display. And then I'm going to show you the graphic display. And then I'm also going to, I have since last episode also received the LCD Shield with the buttons on. I'm going to talk about that a little bit because you cannot use it with the off-the-shelf software downloads or samples that are on the Arduino website. And it's a real simple fix, but if you got it and you didn't really look at that close, you had to figure it out, and I'll go through that as well. And that's also from sainsmart, and that one worked fine without any issue. So let me first hop over here to the computer, and as we look at this drawing, you remember this from last week, we actually had 4 data pins, an RS pin, an RW pin, an E pin, plus 5-volt and ground pins. So the actual pins used in the Arduino was actually 7, because we used 4 data, we didn't use 8. However, you optionally can use 8 if you want to do extended character sets. So if you want to do that, you'll be using a total of 11 pins off the Arduino. Well, depending on which Arduino you have, you can very quickly run out of pins. The Arduino Uno only has 13 pins, digital pins, and 2 of those are reserved for read and write. So you really only have 11. So by using this LCD, the Arduino Uno, you've used up all your digital inputs or outputs with this one LCD display. In fact, you couldn't add much more to it other than the analog input or outputs if you attached an 8-bit display. Now, we only used 4 bits. We used 4 data, RS, RW, and E. So that's 7 of the 11. So that would leave you with 4 additional pins to do something with on the digital pin side. So that you can see how quickly you can use up resources on an Arduino. So if we look at the serial LCD, what they do is they add, I'm going to call it a MUX, depending on who you talk to, they call it different things, but basically it's a multiplexer, and it has pins from it to the LCD. And then it talks to the Arduino using 2 pins, the data pin and the clock pin. Now you still need 5 volts and ground, but that doesn't really take up any of your pins. But that takes the 7 or the 11 pins of the 4 8-bit LCD that we used last week down to 2. So that there frees up a ton of pins. Where it gets confusing is how do you communicate with the LCD? There's not very many libraries out there, and the ones that I had found actually didn't work very well. The MUX uses a protocol called I2C, and it's a 2-wire protocol. So basically you have a clock wire and a data wire. And if you look, this is actually developed by Philips Technologies, I believe, or Philips Electronics, whatever they are. And if you go to the website, you can get lots of information. You just look up I2C and you'll find it all over the place. But basically, what it does is it has, like I said, two wires, a clock, which is SCL, and then SDA, which is the data. And as part of the protocol, when it communicates on the wire, you have one master and a bunch of slaves. The master can request information or control any device that has an address on it on that line. So we'll look at the protocol next, but basically what happens is you send out a start, and then you send out an address, so which device you want to talk to. Then you send out the command register, or the command address, register address they call it, I believe, and then the data. So what it could be is one device may have 10 different things it can do, so you address the device, then you put the address in for the function that you want to do, and then the option for the function. And on an LCD, it's pretty simple because you're not going to read from it, you're going to write to it all the time. So the protocol allows for reading and writing, and we'll talk about that next, how they determine what you're trying to do with it. Reading is a little bit more complicated than writing, but not much more. So I'm actually going to focus on this episode, since I'm working with LCD, is just writing. I'm not going to go into the whole I2C protocol in great detail, just enough so you can understand what's going to happen with the LCD. So let's look at the protocol a little bit. And what I said before is, you have a start, and then you have the device address. Now everything is in 8-bit, because it's 8-in-1 data, basically. So you have a start, then you have 7 bits of the address. Now here's where it gets a little confusing and confuses some people, because it actually uses the top 7 bits of the address. The lowest bit, which is the 0 or 1, is actually a read-write bit. So if you have an address of, say, 2, you really should have an address of 4. That's how you're going to address it if you look at it in binary to decimal conversion, because that the least significant bit is actually used for read-write. So 7-bit address, and then an 8-bit read-write. And we'll talk about this maybe in another episode about the I2C protocol, but just understand that the very first byte is an address, and it's read and write. The next item is a register address, and this is basically, I call it a command address, but it actually holds data. If you're reading data, it holds data. In the case of the LCD, different addresses do different things and can turn on different pins. So you'll see this in my example. Let's do some of the code, that I actually have different addresses for doing different things on the LCD. For example, turning the display on and off. And then the very last one is the command data. And a register can have multiple commands. So you could have, in the case of the register to turn things off and on, it's basically off or on. But if you're reading like a compass, you may give a register address, and you want to say, I want to read the direction. So that'd be your command, is read direction. Or if it's a GPS type I2C interface, you could be reading direction, your speed. You could be reading multiple different things. So the register address may have multiple commands that you can run and get data from. And then you send the stop afterward. So in the case of our LCD in this mux, what we're basically doing is sending this mux commands to turn off and on each pin. So let's go back and look at that real quick. And in the mux, we send data to say turn pin 1 on, send data to say turn pin 2 off, send data to say turn pin 3 off, turn pin 4 on, and then you want to turn on pin 11, which is the enable. So you basically send a command for each line, and then you send a command for the RW, which lets the LCD read the data. So it would seem like it's a lot more data going back and forth, and actually, in reality, it is, because you're giving a command for each individual pin to function. But on a text display, it's so fast you can never be able to tell the difference. So I have had that question in the past: is it slower? Well, I've actually never measured it. The data can run up to 300 hertz, I think, is the default for I2C, but I've seen it go as high as like 3.8 megahertz. But 300 hertz, 300 cycles a second is more than enough to just update a display in a second. So I don't think it's a visual thing. I can't really tell the difference myself when I run it. It seems very fast to me. So for text displays, I wouldn't worry about it. Now, getting into the graphical displays, now that I see how they are working, and they're also 8-bit as well, so it would require more data to go across the line. It would be probably noticeable. I might have to experiment with that at some point, but the graphic display that I have does not have a mux on it. All right, so let's go out of here, and I'm going to switch over to the Arduino. And you'll see the display. This is the 4 the four line display that I had before, 20 characters wide. Had it last week, didn't have it working. Now if you take and I turn this over, on the end here, you're going to see I have 4 wires. Basically, I have ground and 5 volts. Then I have the SDA and the SCL. So I have data and the clock right here. So I've taken this display, and this whole display runs off of four wires. Only 2 pins from the Arduino itself. If you look at the Arduino, you see here's the 2 pins that I'm using. These 2 pins are 5 volts and ground. So I've taken all of those wires that were on the other display and brought it down to these 4. So let's go look at some code real quick. And the way the code works from the library, actually I found a library that I liked but did not work. So I've had to modify the library. And let me bring up that. Okay, so let's look at the code that runs this LCD display. Last week we had the LCD library, and this is actually very, very similar. I went looking for a library online, did not find one that would really work with this, and then I looked at the code from sainsmart, and it did not work either. But after I looking through their code, I figured out how it worked, and I, for the most part, modified their library to make it work and added a few additional things to it. But if you remember last week, we had liquidcrystal.h, and then we would define the class, and then we would do set cursor and print and all that. This is all the same, so it's very easily adjusted. So what I've taken was the hello world that was from last week, which is the default in the Arduino project, and I've now modified it so that it works with the I2C. So all I've done is included the library liquidcrystal.I2C. I've defined the LCD, and remember I said in the protocol the very first byte that goes across is the address of the device you want to talk to. Well, what sainsmart's done is this device address is 03F. If they would make a display that would have a different address, you could actually put both addresses on the same bus and display different things to each one of them. And they would work, together with each other on the same bus. But this apparently is hard-coded in their hardware to use 03F. So the next thing is the number of characters in a line and then the number of lines. So this line defines the LCD class like it did last week with a few additional parameters in it. And in our setup, we init the LCD, which goes through and turns the display on and off, and however it's set up by default. You can see right here, I turned the backlight on because by default the backlight is turned off, but I can easily turn the backlight off and on right here. And then we get into things that are very familiar from last week. LCD set cursor. So I'm going to the very first line, the third position in, I'm typing out the let's make it name right here. And you see I go to the next line, LCD displays, continued, and let's make it. So it works very similar after you initialize it as you saw last week. The hardest part of this was figuring out how to get the 2-wire interface to work. And now I've done that, and I will put that library on the website for download. And if you have a sainsmart, you can just download it and start using it. It'll work right off. I'm not sure which other displays it works with because that's really the only serial display that I actually have or that I can find. I have other displays in a box, but I haven't found the box yet. But I don't think they're all parallel as well. And let's go back to the Arduino. Let me show you, or to the display. I want to show you something on the display. And if you look on the back, actually look on the front first, you can see here on the front, you probably can't read it, it's too small on the screen, but right here are all the parallel interfaces. Last week we dealt with D0 through D8. Here's your 5 volts, RS, RWE. So these are all the same parallel pins, and this board would work as a parallel board if I would unsolder this additional board in the back. So what sainsmart's done is they've created this little daughter board right here, soldered it onto the display, and this is the serial to parallel interface that we're talking about. So this chip talks I2C, and then each of these pin outs go to the pin on the display. So this is the MUX chip right here, basically. That's what that ends up being. So this display would function as a parallel just by taking this board off and wiring it in directly. But we've taken, and this board would require, well, it would not require eight pins necessarily. Again, it's based on what kind of characters you want to display. But you can see it basically takes a regular board. So you can buy these boards like this by themselves. So if you have a display and you wanted to do an I2C interface, you can search on the internet for I2C to parallel LCD, and you'll find little boards like this that'll solder in. So, okay, that's kind of all I wanted to go over with this serial. I also wanted to talk about a little bit then, and after I saw the difficulty of getting it to work, I thought it'd be helpful for other people to maybe get that, especially if you're really new to programming. Figuring out the problems with the library is not necessarily trivial. So now the other one I want to go to is I've been playing with this other display this week as well. I'm doing it over here. This is the graphical display. Now this is still a parallel interface. In fact, if you look at the back of this, you're going to see I have a lot of wires going in here because this actually requires an 8-bit display. And I can kind of explain that here in a little bit. But we still have power, ground. You have your 8 different data channels, and you have RW. You know, the same pins you had before. Your E, RW, all that's in there too. And it's actually going to a different Arduino, which I have right here, just as the Arduino Uno that I used last week in the demonstration. So you see I have all the pins wired up to it. This display works much differently. In fact, I'm going to show you some of the code that it took to do this, and I will tell you that these text right here is the built-in font, but placement of those characters is difficult, to say the least. Drawing a circle isn't that bad. You basically are drawing each individual dot in the circle, so you have to write a little program, which I did. I have squares, lines, and circles that I can draw. But what I have found is if you wanted to do any kind of other font other than this block font, and to make it flexible, you have to create your own font. So I'm working on a library now for this display that will display fonts. So I'm building the font, pretty far along, and actually have some of the font code to draw it out done. And so hopefully in the next few weeks I'll have a library for this that will actually do fonts, and you can place it different sizes, different locations, stuff like that. This is much more difficult than just sending out text though, because it really does require go to this XY and it's on or off for the bit for the display. So it's a lot more cumbersome to display. And so far I have not found a good library for that. I've found examples of pieces of libraries, which is where I kind of learned how it worked, but now I'm going out and creating my own. So I'm going to hop over to that program. Let me get that real quick. The library that I have, or the program that I've written that did that little circle, and just talk about what it requires to get this far. You see in the beginning I initialized the library. I don't really define a class because the class is defined in the LCD 12864, which is the chip that runs the graphics on this board. If you go out and search the internet for LCD 12864, you'll find examples of what it can do, but not really any decent libraries that I could find specific to the Arduino at least. So I initialize it. I have to wait half a second because it has issues during initialization if I try to continue. I turn on the render engine, and then I draw a circle, and this actually draws on an off-screen buffer. So then what I tell it to do is I tell it to render screen buffer 1 to the screen, and then I turn off drawing. And when I turn off drawing, I have to wait a millisecond, and then I can send out characters 1, 2, 3, and I'm sending out 1, 0, 1, 2, and A, which you saw on the screen. And then I create another routine called setString, and I send out CDE. This is how I'm learning how it would work. So, and then I turn drawing back on. So if drawing is on, I cannot write text out. The issue is when you turn off drawing and you send text out, it sends it wherever your last location was. So it's not easily set to the location. And just for learning this down here, you see I've actually created a setString variable, which basically takes and does setChar, which I wrote. It sends out the pins, and you'll see I have to convert whatever it is to ASCII, and then I have to do the ASCII bit level. So each pin that I have to set, so I basically send out each pin for each value of the letter, and that's how I get the text on the screen. So it's like I said, it's a lot more complicated to do, and that's just sending out a letter in text mode. To do any kind of font, you have to send it out in bit mode, and set the pins and send it out in bit mode on a per dot location. So this is going to be a fun one. I've been enjoying playing with it. It was a little frustrating at first. I was actually having a little bit of frustration with the I2C, and I took a break from it, went over here, and a little frustrated, but I got this to work, and that gave me the energy to go back and figure out what was going on with the I2C as well. All right, so that's the basic law I wanted to cover this week. Real quick one, I wanted to just go back to the LCD, and in the event that you have received or purchased a display that was I2C, then you could not get it to work, which seems to be a pretty common thing. Especially if you look at if you got a SainsMart, when you go and look at the website, the comments from the people are that they can't get it to work, and this hopefully will help those kind of people that are having issues. Now, there's one other thing I mentioned last week that I was going to get, and I did receive it, and I'm going to show it to you. Let me get this one out of the way, and let's go back over to the other camera. All right, so we'll move this out of the way. What I got was, and this is from SainsMart as well, it is a Arduino Shield, basically plugs right on top of the Arduino, has an LCD display, and has some buttons on it. So when I first got it, I was thinking like, wow, they're using a lot of pins, but they're actually doing some things in here that are making the pins much fewer. So I don't know if they're wiring all pins up. I haven't looked for the 8-bit, but I think they are wiring all pins up for the 8-bit. So that's going to cause a problem if you're trying to use a lot more pins. What they did with the buttons though, and I'm going to plug this in here, I'm going to show it to you in a second, is there's a resistor for each of these buttons. And depending on what button it is, it sends back a different voltage to the analog input. And they, on their website, have the values for those. So by plugging into the Arduino, it sends different voltage back on pin A1, and you can read that and determine what button is pushed. So they're only using one pin for the Arduino for all the buttons, with the exception of reset. Reset is actually the Arduino reset, and it's right here on the end. It is an actual button. So let me unplug this other Arduino real quick. This is the one we were just working with. And take off the display. So this is an Arduino Uno right here. And I'm going to plug this right on top of the Arduino. So we put it like this. So there we have the Arduino. You can see it sandwiched together with the Arduino. And I'm going to plug it back in. That's not going to do anything because I don't have the right code on it. I'm going to show you the code in a second, because there's one thing that's important about this. I'll leave it sit right here. And I'm going to go back over to the code. Let me get out of this one. And this is the hello world from the Arduino, with the exception of the default hello world on the Arduino uses pins 11 or 12 and 11 and 5, 4, 3, and 2. Well, this Shield does not use those pins. It uses 8 and 9, and then 4, 5, 6, and 7 for the data. So unless you change it to 8, 9, 4, 5, 6, 7, the display is not going to work. So I'm going to display or upload this, and then we're going to go back over to the Arduino. And there you go. There's the hello world. So that's something that's important to remember if you get one of these. They're actually kind of cool because it's really quick for debugging stuff. Like I said, the only concern is the number of pins that it's using to display. It looks like it's using 8 data are connected, and then the 3. So it's using all 11 pins. In the case of this Arduino, I've used up all of the pins that are available, and one of the analog inputs I've used up as well. And that one input is used by these buttons to display values. Okay, so what I want to do real quick while I have this program up is I want to show you what I mean by the different input levels on analog 1. So I'm going to take the hello world program, and we're going to make a change to it to show you what the button is doing. So let me go over to the code, and down here where it's printing the number of seconds, we're going to delete this, and we're going to replace it with analog read for pin 0. And then I'm going to upload this and go back to the Arduino. Okay, so the default when no buttons are pressed is 1023. So let's press the very first button, which says select on it. That button returns 7383. So it goes back to 1023 when we don't press it. Let's press the left button, 5013. Let's press the up button. That's 1403. Let's press the down button. That's 3,243. Let's press the right button. That's 23. And of course the last button is reset, which is the actual Arduino reset. Actually, if I press that, you'll see the Arduino will go through a reboot. And you actually won't see probably much happen on the display because it's going to continue to be 1,023 because we're not sending any data to the display because it just restarted itself. So that's how they're doing the input. Now if we go back and we look at the code again, all I'm doing in the code right here is analog read. So I'm reading the value in on the analog input, and based on the resistor values that are being used when you press certain buttons, it returns a different value. Now, one of the things that they have done is on their website, they do have some code for this, and they have values in a header file that you can use, and by using some of their functions, you can quickly take input for the buttons. So this unit itself is good for some things. I mean, I hate to say it's good for developing. It's good for prototyping probably, because ultimately you're not sure what kind of pins you're going to use or what kind of inputs you're going to use. But in the event you want to have a little bit of control over the unit when you're doing some testing or some development, you can use this type of input. I don't think I'd recommend it being in a production type of piece of equipment, but it would work fine for prototyping, which is how probably I'm going to use it. Rather than taking a breadboard like I did a couple episodes ago and putting buttons on it, I will take and use something like this just to get through the prototype stage. And then you ultimately move into final testing using either a breadboard or wire wrap, something like that, before going into production with a board. But I wanted to show you that board. I talked to you about it a little bit last week, and I ordered one and got it for this week. And it actually is pretty nice. It's very well documented compared to the LCD I2C interface from the same company. And actually, if you go out and the display itself, which is this display right here, which is the 4-line 20 characters, is a nicely built display. It's very solid. It feels very good. So I can definitely recommend it if you can get it to work. And if I give you the libraries, you'll get it to work real easy because it just pretty much drop the libraries in and start using it. So it works really well. And I'll put instructions on how to install a library into the Arduino as well on the website where I put the library for this particular display. Overall, it's a nice display. It's not very well supported on their website. That's all. Definitely, if you can get it to work, I recommend it as being a decent display. It's nice. All right, so that's all I wanted to cover this week. I do want to remind you that we do record this live, and now we're going to start recording this live on Tuesday evenings, starting around 7 p.m. Instead of Wednesday evenings, we're moving a show from that's going to be now regular on Wednesdays with some other hosts that are available on Wednesday evenings. So this show is now on Tuesday evenings instead of Wednesday evenings like it was before. If you are not watching this live, come and join us, watch it live. We keep a chat room up on the screen. You can talk to us all the time. We watch the screen, answer questions. In fact, the interactivity with the chat room is very nice. Now, tonight, there's hardly anybody in the chat room because we're recording it on a different night. So hopefully we get that issue solved in the next couple of weeks, because the chat room is very nice for us. It's a great way to interact with you. If you are watching it live, did you know you can download it? So you can download us a number of ways. You can go to iTunes and download us on iTunes. You subscribe so it just comes down automatically. You don't have to worry about when it's available. It just comes down. If you're watching it on YouTube, click the subscribe button. That way you get notifications when our next episode is out, which is every week now, coming up on Tuesdays. Like I said, we'll record on Tuesdays. We'll generally have it out the next day sometime after it's edited. But we do very little editing. In fact, if you watch live, you'll see we do very little editing. We pretty much record as we go, and what we do is what goes out. If you want to have a Twitter account, follow us on Twitter, and you can get all updates from us that way as well. Another way to get information. We also are now on TiVo and Roku, and we have a couple other things coming out here sometime soon that you can get us on that way as well. If you have a Facebook page, please like us. It helps us keep other people finding us and hopefully of value to them as well. So it's the best way to get them to be able to find us. So appreciate everybody's time, and I'm going to do sensors next week, I promise. I have the sensors here. I've been playing with them, but I just felt that this week, since we were already on LCDs, I just do a short little follow-up to the previous week. And I'm already working on some future projects based on suggestions. So if you have suggestions or comments, you can go to the website. You can call us and leave us a voicemail if you want. Let us know what you want to see. If you want us to, you want to send us a video, we love to see that stuff as well. Record a video, upload it to like YouTube or somewhere on YouTube, and just send us a link to it. And that's the best way. Please do not send us the videos via email. Most of the time we probably won't get them because they're too big, and we would prefer to be able to watch them on somewhere like YouTube. If you do leave us a voicemail on our Google Voice phone number, don't worry, nobody will pick up. That is strictly a voicemail system, and we get forward to those voicemails as soon as you leave them. So we do appreciate your information, suggestions, things you want to see in the future. I'd love hearing from you. So, all right, thanks again. This is Let's Make It, and we'll see you next week.